morning to everybody. Myself is Dr. Manikanta from Mlritm from the Department of Electronics and Communication Engineering. Today I am discussing about the subject called digital signal processing. The digital signal processing. What is the need of studying that digital signal processing? Actually, you know about that. The thing here is when you are studying about any course, we have to know what is the outcome of that course. We have to know the outcome of that course and we have to study that course. Here, the digital signal processing also have some outcomes and some modules to discuss here. So, coming to the my presentation content, today we will discuss about the what are the objectives of course objectives and what are the course outcomes and whatever the different modules we have in this digital signal processing and what is the basic concept of digital signal processing means what is signal processing, why is using a digital signal processing, what is the difference between analog signal processing and digital signal processing, why you are coming to the analog signal digital signal processing instead of analog signal processing, all we will discuss here. So coming to the presentation content, today we will discuss about the course objective and course outcomes of the digital signal processing and also the course syllabus of the total 5 modules is there. First one is introduction to digital signal processing and second unit is digital Fourier series and discrete Fourier transform and fast Fourier transforms, and unit 3 is IIR digital filters and FIR digital filters and how to realize the digital filters and how to use for multi-rate signal processing. These are the 5 modules we will discuss in the DSP subject. Coming to the course objectives, what is the course objective? The course objective is nothing but why you will study this units out of 5 modules. The first unit module, basic concept related to the analysis of processing of digital signals. It tells about the basic concept of the signals that in the manner of digital signals, and then fast computation of DFT and appreciate the FFT processing. Coming to the designs of IIR digital filters and analyze and synthesize is the third module, and fourth module is designs of FIR digital filters and analyze and synthesis of the fourth module. And last module is structures of digital filters and equivalent in multi-rate signal processing techniques. Here we will tell about the multi-rate signal processing and the realization of digital filters and what is the course outcomes. After successful completion of this course, the student able to know what is the fundamental concept of digital signal processing for understanding the system characteristics, and also he know about the discrete Fourier transformations of the different form. Those are discrete Fourier series and discrete Fourier transform and also the post Fourier transforms. And coming to the third module, here the student will able to know about IIR digital filters, that is infinite impulse response digital filters. And CO4 he will study about the FIR digital filter, that is finite impulse response digital filters. And coming to the last module, he will know about the realization of digital filters and also how it will be communicated for the multi-rate signal processing. And this is the basic course outcomes of the our 5 modules. And coming to the detailed syllabus, in the unit 1 we will discuss about the introduction to digital signal processing and what are the different types of signals and systems you have. Actually you have the two different types of signals and systems, that is continuous signal system and discrete signal systems. But here coming to the digital signal processing, we will mainly focus on the discrete type of signals. That's why it is called as a digital signal processor. And coming to that, after that conversion of continuous to discrete time signals, every signal has to be every signal is in the form of analog, but for digital signal processing, if you want to process the signal, it has to be in the digital format. So that's why we have to convert the continuous signal to the digital signal, and this is possible by using the sampling theorem, that is conversion of continuous to discrete signals. And next how to convert the difference equation to the transfer functions or any form by using the linear constant coefficient difference equation and its solution. and we will check the system response with the different inputs: zero input response, zero state response, and impulse response, and step response. And finally we will know about the how to represent a signal in the frequency domain. And coming to the unit 2, here we will convert the time domain signals to the frequency domain signals. And coming to here, I have to elaborate about the time. Here, whenever in signals and systems, we will study about the continuous signals. That is, the signal is represented by x of t. But here, the digital signal processing, here we will use for time signal, the signal is denoted by x of n, and for frequency, we can use x of k. So that's why the formulas whatever you are studied in the signals and system, those are similar to here, but there we will use integration of minus infinity to infinity. But in the discrete time signals we will use summation n equal to minus infinity to some value of infinity. So the thing here is, for continuous signal we will use only integrations, and for discrete signal we will use summations, because already you know about the basic concepts of the integrations. And what is the difference between continuous and discrete? Means continuous is nothing but which is used at the any interval. Means if you take 0 to 1, the infinite values of 0 to 1 will be possible to no. But coming to the discrete signal, that will be defined at the particular concept. Suppose I want to know about 0 comma 1 samples, then it will give use at that time only. That is discrete. So for conversion of the discrete time signals to the frequency domain signals, here we will use three types of transformations. That is discrete Fourier series, and next one is discrete Fourier transform, and next last one is fast Fourier transform. This is the three different ways to convert from the time domain analysis to the frequency domain analysis. So coming to the discrete Fourier series, here we will study about what is how we will represent the discrete Fourier series, and what for a periodic sequence, and what is the main properties of a DFS. And discrete Fourier transforms properties are, here we will study about the discrete Fourier transform and the properties of DFTs, and by using DFT how to convolute a two sequences by using different methods called overlap method and overlap save method. These will be the two different methods for convoluting any type of sequence by using DFT. And finally, fast Fourier transform. And here we will know about how to why fast Fourier transform. Before going to that, DFT has several computations for a long distance sequence. Means if it is that the sequence of the number of samples are increases, it is not possible to compute the such number of sequences. So coming to the fast Fourier transform, the number of computations will be decreased here compared to the DFT. And here the fast Fourier transform using butterfly diagrams, we will compute the given signal. And next one is unit 3, IAR digital filters. Here analog filter approximation, IAR digital filters. Every digital signal processor has filters, and that filters are IAR digital filters and FIR digital filters. In these two units we will know about what is what is digital filter, and how is response to the infinite impulse response and finite impulse response. And we have different scientists, and those are derived different approximation, Butterworth and Chebyshev filters, and design of IR filters from analog filters, they are designed from the analog filter, and step and impulse invariant techniques, and bilinear transformation method, and spectral transformations. This is the unit 3. And coming to the unit 4, and here whatever the study of digital filters in two types, IR digital filters and FIR digital filters. Unit 3 will describe about the IR digital filters, and unit 4 describe about the FIR digital filters. Here also we will characterize the FIR digital filter and frequency response, how it is response to the frequency, and design of FIR digital filters, and what is the different methods to develop that Fourier method, digital filters using window techniques. And this is about the comparison of last IR and digital FIR digital filters. And last module is realization of digital filters Applications of here we will know about the applications of Z transform, solutions of difference equation of a digital filter, system function and stability criterion, and frequency response of a stable systems, and how the realization of digital filter by using direct canonical cascade and parallel form. See how we can realize the digital filters by these four methods, and this will be derived in the last unit. And the multi-rate signal processing. Here, introduction, decimation by S factor D and spectrum of decimator and interpolation and the spectrum interpolator, sampling rate conversion by a interpolation and decimation, spectrum sampling rate converters. Here we will study about this unit 5 module. And coming to the course syllabus, here we will use John G. Procris or A.V. Opinium. Here the two textbooks we have, and Shalivana and Nagurkane and Ramesh Babu had the reference books. The thing here is the Nagurkane and Ramesh Babu will be good for the digital signal processing. And coming to the basic concept of digital signal processing, before going to the block diagram of digital signal processing, we will reveal what is signal, what is processing, what is signal processing, what is digital, what is the difference between digital and continuous, that we will study now. Coming to the signal, what is a signal? Signal is a physical phenomenon that carries or convey information from one place to the other and represent as a function of independent variables such as time and distance or space or etc. Means a distance, the signal is nothing but and contains an information which is used to transfer from one place to the another place by with respect to such independent variables such as time and space and also a distance etc. We have different independent variables, and also depend upon the number of independent variable, means depend upon the number of independent variables. Signals are classified into different types, that is one dimensional signal and two dimensional signal. And what is one dimensional signal and what is two dimensional signal? Up to so on you can have any number of type of signals. What is meant by 1D and 2D and 3D etc. Here 1D dimensional signal will represent a independent variable. Here the independent variables such as time and distance and etc. Those, if it is only one independent variable, then it is said to be a one-dimensional signal. If it is two independent variables, then it is said to be a two-dimensional. If it has three-dimensional, it is a 3D signal. And like that, we will classify the signals based upon the number of independent variables. Okay. This is the simple signal diagram, sinusoidal signal, which is having time and amplitude of the signal. And coming to the what is a signal processing? Nothing but you have signal. If you want to extract the information from that signal, we have to process that signal. It is nothing but a signal processing. Signal processing is the analysis, interpretation and manipulations of like sound, images, time varying measurement values and sensor data etc. Nothing but here he is saying that the signal processing is nothing but grasping or taking the information from the signal. And the signal processing, you have analog signal processing and digital signal processing. What analog signal processing, if you see here, I am clearly given a diagram, the continuous signal. Here the continuous signal is nothing but a which is used to analog signal processors, and digital signal by using samples. This nothing but stems I am using. These are used for the digital signal processing. This is also sinusoidal, but here the sinusoidal is represented for every value, but here for particular samples this is discovered. And digital signal processing, where it is the basic block diagram of a digital signal processor. If you see here, analog digital converter and signal processor and digital analog converter and audio amplifier. The main drawback of the digital signal processor is it required pre and post equipments. Means compared to the analog signal processing, the digital signal processor need an extra equipment called the converters, means analog to digital converters and digital to analog converters. Why? Means here the every signal is exist in the analog manner, but you want to process that analog signal by the digital signal processor. Here we will use digital signal processor, DSP. So you have to convert that analog signal to the digital signal. So we need an ADC block, and after that signal processor, it will give only digital output. What it will give? Digital output it will give. But we need an analog output to transmit that to the outside. Here we will use analog digital to analog converter, and this analog signal will give to the amplifier to increase the frequency or strengthen the signal. So this is the basic motto of a digital signal processing block diagram. So if you coming to the digital, operating by use of discrete signal to represent the data in the form of numbers, not in the continuous time. Signal is parameter electric quantity, and we have different types of signals, and processing is a operation performed by the programmed instructions. This is the basic block diagram of a digital signal processing. And coming to the signal processing needs, what is the need of a signal processing? Why you have to use the signal processing? Why? What is the purpose? Actually, here if you see, here I clearly given a diagram to know about that. Here if you see, here I have a sinusoidal signal with respect to time and frequency. If you see here, if I didn't do any signal processing, after while it is transmitting from one place to the another place, in the from the air or any through media, the distortion will comes exist into the signal, and after the distortion the signal information will be vary. Means whatever the information I have passed from one place to another place, that will be vary. So to eliminate this distortion, we will use a signal processing. So from the signal to the distortion, from the signal will be affected by this distortion. After affected by the distortion, the signal will vary from varies the information. So after the signal varies the information, I will transfer that to the signal process. This will process and eliminate the distortion and gives the pure signal. This That's why we need a signal processor and the existence of a communication. And principles and operation, digital signal processing consists of mainly, I have already told that, ADC blocks and the DSPs. And also away from those, digital signal processing consists of anti-aliasing filters. Those are already I told that IR digital filters and FIR digital filter in the introduction. Those are also need, and ADCs and digital processors and DACs and reconstruction filters are also need. Here we will for D to D converter, here we will use a digital filter, and after that after the processor it goes to the DTA, and here we need a reconstruction filter for getting the original signal. So this is the principle and operation of a DSP. Thank you.